Hey everybody, welcome to our virtual class this week for Algebra 1. I know you guys had your midterms last week and you're excited or maybe not excited to see them. We'll talk about those next week, but just as a reminder, right, so we have some tutoring this Friday, right? So if you want to join into the tutor session, then it is Friday this week. Okay, so Friday, and that would be the 4th. Okay, so Friday the 4th, and anytime from 12:45 to about 2 p.m. Okay, your parents have the link, but you might also have it from them. If they don't have it, just make sure you let them know that you need it, and they'll let me know. Okay. So bring any questions, say come as early as you can to that to benefit from other people asking questions as well. We have some time in class. This week we don't, obviously, but it's important that you ask questions. If you don't know something, then it's only going to help you to ask those questions. All right, so let's go back then. Let's go to our lessons for this week. So we always start out with our supplement, so we're going to stick with that same convention here. Okay, so we have week 9 supplement, so go ahead and get that out. You can always pause this video as we get things out. So we have our week 19 supplement. Okay, so for week 19, we're going to factor, right? So we've done that already. So if we have something like ax squared plus bx plus, bx plus c. Probably did that last week, or not last week, but before the midterm, right? So we had something like x squared plus 5x plus 6. So you can see in this case, right, the a is 1, the b is 5, and the c is 6, okay? And then we did something like if it multiplies to, right, and we'll talk about this a little bit more in our lesson. We had something set up like this where we had a t-chart. So we had if it multiplies to a times c, then it adds to b. So this is multiplies to, this is adds to. Okay, so let's think of MTAC. So a times c, so that would be 6, and then it adds to b, right? So our b is 5. So then when we think of two numbers there, we can think of 3 times 2, right? 3 times 2 is 6, and if you do 3 plus 2, then you get 5, right? Okay, so then those are 3 plus 2, where I wrote that, 3 plus 2, and you get equal to 5. Okay, so then you can break it down into something like this, right? We broke down, we just said we can just add those numbers up, so x plus 3, x plus 5, or x plus 2 rather, right? And then to check that we got the right answer, we can go ahead and use the distributive principle, and so that means that we'd multiply the first terms by the first terms, and then the outside terms, and we multiply the inside term, and then we do the last term by the last term, right? So the FOIL method right there, right? So you can always look up something like this if you don't remember, but this is the FOIL method, okay? So you can peruse YouTube and look over it again, but that's basically what that is, right? Okay, so now let's go ahead and move on to the rest of the stuff that we have at hand here. So we'll go back here to what we had. Okay, so we'll get rid of even our multiplies to, adds to stuff. And we'll just talk about this example we have on there. Okay, so factoring is just dividing out what we had, right? So if we go back here, the example that we have was 3x squared plus 15x plus 2x plus 10. Okay, 2x is a little funny. All right, so if we're going to factor out by 2's, right? So we're factoring by grouping. Okay, so we can title this, we say factor by grouping. By grouping. My writing's not real good on the iPad, but anyway, you guys can see that factor by grouping. So we're going to look and see if we notice anything about what we could factor. Okay, so hopefully you can see that for this first one right here, or these first two terms right here, we'd factor out an x and we could factor out a 3, right? So we'll factor out a 3 and an x, okay? And then if we factor a 3 and an x out, right, in order to get back to this first term, we just would have x. And then for the second term, if we factor 3x out, we'd have plus 5. Okay, and then for the second set of terms here, 2x plus 10, you can see that we can't factor any x's out. We could factor 2 out there, right? So we could do plus 2, and then actually to keep with the convention that we were doing over here, right? So we can see our factor that we're taking out. We have 2, and then here we factor 2 out of 2x. Then we just have x, and then we have plus, and we have 5. Okay, so now what you probably will notice is that x plus 5 is over here, and x plus 5 is over here. So we could say that both terms have x plus 5 that can be factored out. Okay, so then when we go to the next step, we could write x plus 5 as part of both of these, right? So we could factor out the x plus 5, and then for the rest of it, then we just would write the other terms that we have, right? So if we had the last two terms we had 3x plus 2. Okay, so you can see we factored out this green part here, right, is x plus 5. And then we have 3x plus 2 here. So let's see. Yep, so you can see that. And the best way to check yourself, right, is to multiply these through again, right? So we could use our FOIL method again. We can multiply the first term by the first term, and then the outside terms, then the inside terms, and then the last two terms there. If we multiply those out for this first one here, so this is our f right here, we'd have 3x squared. So that's what we have for our first term at the very top left there. And then if we do these outside terms, so this O here, we have x times 2, so that would get us 2x. So you can see that's actually our third term up here, right? You can see my marker up here, right? That's our third term. And then if we do I right here, so our inside term, we have 5 times 3x, and that would be 15x. So that would be this one up here that I'm drawing above. Okay, and then if I do my last terms, then I have 5 times 2, which is 10. So that's my last number up here at the top. So then you can see I factored out properly. Okay, so there's that, and then let me show you a little bit different way. Okay, so if I showed you this, instead I wrote 3x squared, and then I wrote plus 2x, I wrote plus 15x, and then I wrote plus 10. Okay, when you're factoring out by groups here, right, you might think of these first two terms as a group and these first two terms as a group. But what could you notice immediately? Okay, and maybe what you might notice after a little while is that there is no common factor between, or at least there's a common factor in this first one, right? We can see that x is a common factor for this first set, right? You can see that x is common there, right? And nothing over here is really common. Like I can factor out, I could factor out 5 for this one, but for this first set where I have x over here, I can factor out x, but that's it. So now I'd want to think of it like this. So I'd think of, okay, what are two terms that have common factors? So actually it'd be 3x here, and it'd be plus 3x squared, and then 15x here. And then I think that 2x and minus 10 have common factors, right? So then that would lead me to right away go ahead and write this in a different order, right? I could write 3x squared and then write plus 15x, and then I'd write my plus 2x minus 10. So now I have them grouped together, where I can again factor this out, right? I have a 3 and I have an x that are common to both of these first terms right here. And then if I factor out 3x from this first term here, right, so we'll call this term 1, we'll call this term 2. So I'm going to factor it out of term 1 and term 2. And then I'd have 3x, and I'd have x plus 5 here, right? And then if I'm moving over here to term 3 and term 4, then you can see that I can factor a 2 out, but I can't factor an x. Factor the 2 out, and then I would just have x for this first term. Whoops, I've messed up this. This is plus 10 right here. Okay, plus 10. So then this is plus 5 here. Okay, so now you can see again, I have the same thing that I had in the previous example, right? This x plus 5 here, right? It's in both of these. So then I can simply write it. I can either write it the other way where I wrote x plus 5 first, or I can see that if I took my 3x plus 2, so these two blue terms on the previous line, and then I could write x plus 5 like this. Okay, so there's just 8 exercises for you guys to practice this. Like I said, you might need to flip around which order you do, you're factoring out. You might have to factor it out of the first term and the third term, or the first and second term there. Okay, and I'll just say for you guys to start working some of these out, just go ahead and pause the video, and then you can do some practice, and then come back, and we'll start lesson 68. Okay, so lesson 68, we're going to open another drawing here. So lesson 68, we'll just put, put draw to draw. We put lesson 68. Okay, so for lesson 68, we're talking about adding fractions, or simplifying fractions rather. So I think the book has it labeled a little bit differently. The book went ahead and give the title about complex fractions, right? So we'll call it complex fractions. Okay, so any rules for complex fractions are the same as for other fractions. So the only thing that I'll say here for notes is that just say simplify top and bottom. Simplify top and bottom for, I guess you could say before inverting, okay? So before inverting to multiply. And back to this term, right, inverting, right? So we know that if you're going to divide by something, then it's the same thing as multiplying by its reciprocal. Okay, so that's all I'm trying to say here. So simplify the top and bottom before you invert to multiply. So if we had example 1 here, and I should have enough room here, we'll see. Okay, so for example 1, we had x plus y or x over y, sorry, x over y, and then we had plus 1 over y. Okay, so that was our top, and then the bottom was x minus 1 over y. Or I guess it was x over y minus 1 over y. Okay, so I guess I can go ahead and get a little more clear about that. Okay, so it's x over y, and then it's minus 1 over y. Okay, so first thing we might notice, right, is that our denominators for the top part of the fraction and the bottom part of the fraction are identical, right? So there's no reason why I can't write them all as over each other, so then I could write this in equivalent form. I would just write x plus y over y, and then I'd write it as x minus 1 over y. Okay, so those are the same thing. And then if I'm going to follow my step above where I said simplify top and bottom before you invert to multiply, then I simply have, right, the top, right, so the top here is this piece, right, and then the bottom is this piece. Okay, so if I'm going to multiply this, then I can write it as x plus y, or x plus, sorry, this is, right, I think something got messed up here. This is 1 right here. Okay, so let's go back to our pen. Okay, so our pen, we had x plus 1 here. Okay, so we had x plus 1 over y. So then if we're going to follow our steps here for this top piece, right? So this is our top piece right here with x plus 1 over y. And then it says over here, divided by x minus 1 divided by y. So instead, we're going to flip it, right? So then we'll just say y over x minus 1. Okay, so you can see that, right? So that's this piece, but we inverted it, right? Okay, so then if we're going to multiply this across, the only thing that we need to be careful of is that we put a parenthesis. Oops, that parenthesis is not very smooth there. So a parenthesis around this one, and then we have a parenthesis around this one to multiply it. Okay, so then for this top part of our fraction, we just get right, xy plus y. Right, so that's for that top part, and then on the bottom we'd have the same thing, right? We'd have xy for that first part, and then we'd have minus y. Okay, so that would be our solution for that one right there. And then what you can see, just a second, I'm looking at this thing real quick. Oh yeah. Okay, so what do you guys notice about this? So you can notice that what do we have common to all of these? Every single term here has a y. You guys see that? Right, so let's see if I can point at it, right? This term has a y, 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 right? So in fractions, look over here to the bottom left. If you have a fraction like this, if I had 4 over 4, right, then we'd go ahead and say, okay, that's 1, right? These cancel, right? So the same thing is true here. If you have y over y, then these cross out as well, and you get 1. So in this case, for this one right here, let's see if I can move this thing. Can I move it? Oh, I can move it over there. Okay, good. So then if you're going a little backwards here, right, then for this part right here, if you can factor that one out, then you just would have x plus 1 and then you have x minus 1, right? Because you can factor out your y out of all of them because all of them have the y common to those. Okay, so that's pretty much it for the first example there. So let's go ahead and look at one more example real quick. Okay, so if we're going to do this example here, I'm going to do our color palette again. Let's go ahead and start with blue again. And oh, that. Okay, we'll put it over here. Okay, in the corner. Okay, so then for example 4 here, example 4 is very similar. We have a over b plus 1. Okay, and then on the bottom we have x over b plus 4. Okay, so we want to simplify before we can add those. And with any fraction, right, our rules are that we have to have the same denominators. So see on the top we have b for the denominator for that top term, and then over here, right, we can make one a fraction there. We'll just have 1 over 1, and then for 4 on the bottom we'll just have 4 over 1, right? It doesn't change the number at all. But then on the top and the bottom alike, we need b to be our common denominator. Okay, so we might show that by okay, might show that here by saying, okay, we're going to multiply by b over b here, and we'll multiply by b over b here. Okay, so then if we write this in simplified form, then for the top, we'd have a plus b over b. Sorry, this b is, there we go, take the b. And then for this bottom one, we'd have x plus 4b. And then in the bottom, we'd have b again. Okay, so if you remember what we did in our last example, right? This little bar here, so I'm going to underline again, means divide, right? So again, we have our top term here, right? And then we have our bottom term here. So dividing, the opposite of dividing, or I guess the equivalent of dividing, is multiplying by its reciprocal, okay? So then we can write an equal sign here, and then try to fit it onto here, okay? We'll do, so then we would do something like this, right? We'd do a plus b over b, and then we'd multiply by this second part right here, right? So then we flip this one over and we have b over x plus 4 times b. Okay, so you guys write x plus 4b. Let's see here if I can go back and try to remedy my mistake here. At least make it a little bit more readable. So x plus, and then you have 4 times b. Okay. Right, so you can see that that's this term here, and this is this term, it's just inverted, right? So again, make sure you keep your parentheses here when you're doing it. But unlike our last case where we multiply it all through, we can do before we even do this. Remember, when we multiply fractions, we can reduce them, right? Or sometimes we call it cross-reducing. So look for something common on the top and on the top of a fraction and the bottom of a fraction. So hopefully, even if you want to pause the video for a second to look, hopefully you can see that you have something common, right? So you can see that the b is common here and b is common here, so they can cross out. Okay, so then what you have finally for this one is you would just have a plus b over x plus 4b. Okay. Okay, so then let's go ahead and move to the next example real quick. So let's go ahead and go there. So we'd have our blue marker again, and we'll go to example 5. Okay, so example 5 here. very similar, but now we have a negative exponent. Okay, so we have a minus 1 x plus b minus 1 y over x to the minus 1. Okay, so you might remember the first thing that we really like to do is to get rid of our exponents that are negative, right? So we can, that means that we can just go ahead and move them to the denominator or to the numerator to change their sign. So for this first term, we could write it as, we're going to keep it kind of on the numerator here. So if we did x over a, so let's put our division sign here, right? So if we still think about it on the top of this division bar, we'd have x over a, and then we'd have plus, and then in this case, our y is going to stay on the top, and then our b is going to be on the bottom. Now for our x minus 1 here, we can think of it in both ways, but first we'll break it down into steps. Think of it as 1 over x there, okay? So then if we're going to go to the next step, right? So let's go back to our denoting with our pen here, right? This term is our top term, this term is our bottom term. So if we're going to multiply anything, we actually, before we even did that, we can do it this way, but we might want to add our fraction first. Okay, so if we added our fraction first, what is the least common denominator for these two terms over here? Right, we have an a on the bottom here, a b on the bottom there, so we'd say that our least common denominator is ab. Okay, so then we'd have to multiply this first term by b over b. Okay, so if you can see that's clear enough. And then we multiply this term by a over a. Okay, so then we can write bx plus ya, right? And then that'll be all over ab. Okay, and then like I said, this is that's our top term, and then when we think about putting our bottom term over here, we're going to invert it, right? Okay, so then we'd have x over 1. So at this point, you're basically done, right? So with the last part that we might say, we could actually just write it like this. So we have x, and then we have bx minus ya, and then we could divide it by ab. Oops, ab. Right, so you could leave it like that, or if we wanted to multiply it through, then this first term here, right, so this first term that's in the parentheses, we just have another x in the exponent, so it would be bx squared. And then the second term right here would just be axy. Okay, that's our final answer right there. And that's all I have for lesson 68. So you can go ahead and work on some practice problems, pause the video, and then see lesson 69 in just a little bit. Alrighty, so lesson 69. I'm going to move back to blue here. So lesson 69. We have factoring again, right? So we call them trinomials because they have 3 terms. So trinomials. So typically, right, we've talked about it already. With our supplement, we have ax squared plus bx plus c. Okay, so the case that we're talking about here in the last lesson, we'll go into a little more detail about how these are done. But in this case, for this lesson, a has to always be equal to 1. Okay, and our steps for this would be to set up an order. Okay, so set up an order. So the order that you see above here, that's technically in order, right? So it has x squared first, x next, and then a constant c, right? And then next, right, we're just going to identify what our constants are here for A, B, and C. So we'll just say identify A, B, C. Okay, and then next is going to be to make a t-chart. And our t-chart is going to be like this, right? We have A times C, and then we have B here. And then, right, we already wrote it before. Oops, this M doesn't look very nice here. Let's see if I can go back and fix my M. Okay. Yeah, that works. Okay, so M, so it's MT for multiplies to, and then this last part is adds to. Okay. So A, C, and B, and then for 4 is to find those numbers. Okay, so find the numbers, find numbers, and then the last one is just go to write our answer, right? So once we find our numbers, then it's x plus our number 1, and then open parentheses again, and then we do x plus our number 2. So there's our steps there. So I'm going to go ahead and open another page here, and we'll do it for this example 2. Okay, so for example 2, we have x squared plus 3x minus 10. Okay, so we can identify our A, B, and C. We already did that, right? We can, and they're already in order, right? So we have 1 here in front of x squared. We have 3x, so we have 3 for B, and then for C we have minus 10. So we'll make our t-chart. So we have A times C, right? And then for this other one we have B. So we can put our values there if we put ourselves in a room, right? So B is minus 10, and A times C, whoops, backwards here, sorry. B is equal to 3, and A times C is equal to minus 10. Okay. So if you have paper, you can give yourself a little more room, right? And then you can think of it again, right? Multiplies 2, and then it adds 2. So M time. So we first think of multiplies 2, right? So two numbers that multiply to minus 10. Well, 5 and 2 multiply to 10, but they'd have to be, one of them have to be negative, so maybe we'll just think, okay, let's think, okay, so then minus 5 times 2, right? That would be equal to minus 10, but then if you add those together, you would get, what, you get minus 3, right? If you added them. Then if you did the opposite, if you did 5 times minus 2, that would get you to minus 10. But if you add those up, then it gets you to 3. So you can check that one off the list. Say, okay, I think I found my numbers. And then the last step, right, is just go ahead and write our answer. So it's x, and we're going to add our numbers. So then we have x plus 5, and then we'd have x minus 2. Right, and then the way to check this, right, if you remember, the way to check this is to go ahead and multiply them out, right? So FOIL, so we can do a first times our first, second times our second, inside times inside, and then last times last. Okay, so if we wrote that out, this first one we'd have x squared, we'd have plus, or I guess you could say minus, right? But you have plus minus 2x, then you have plus 5x, and then you have minus 10. Right, following what I wrote above there. So then At the end, we don't have any other x squareds we can combine. We have minus 2x plus 5x. So that would be plus 3x, and we have minus 10. So we ended up with what we started with, so we can be confident that we did it correctly. Okay, so now let's look at our last example here. So if we had something that was written like this, x squared plus 5 plus 6x, we have to first set it up correctly, right? So we can see that the order of these things is swapped, right? So in order to make sure we can think about it properly, you might copy it to your page like this. You write x squared plus 6x, and then you write plus 5. Okay, good. So now we can identify our numbers here, and then we can write our t-chart. So multiplies to, and our adds to, so multiplies to two numbers, right? So two numbers that multiply to a times c, so that's 5, and adds to 6. Okay, so now we think of two numbers that multiply to 5, right? And the only ones that really can really come to mind here, right, would be 5 and 1, right? I mean, you get more complicated, but those are the simplest ones you can think of, and 5 plus 1 also adds to 6. So we can check that off our list, right? So now we can write our numbers, so x plus 5, and then x plus 1, and then we can do our distributive property and multiply them out again. So if I go ahead and do that, right, multiply this term, then to this term, and then the inside terms, the last terms, right? So 4. So then you can do this in your head maybe as a good practice as well, right? And then you have plus 5x, you have plus 5 times 1, which is 5. So then you can see that you get x squared plus 6x plus 5. All right, and I think that sums it up for, I didn't write the lesson up here in the corner, but this is lesson 69. So I'm going to pause the video, do some practice problems, and then come back to watch our last two lessons. All right, so we're going to go into lesson 70 here. So lesson 70. Lesson 70 is all about probability. Okay, so if you're playing a game and you have some dice in your hand, you know that it's not very likely to roll one number versus another, from 1 to 6. But if you have two dice, it's even harder to get a really high number, like 12, for example, because that's only one of your possibilities, right? Both of them have to be 6 for you to roll that. So probability is the likelihood of it happening. So it's always a fraction. Okay, so say always a fraction. You can convert fractions to percents though, right? It's always a fraction. So then if we were going to write probability, we'd say probability is the number outcomes chosen. That's divided by the number of total outcomes. Okay, so if you have a coin, it has two sides on a coin, right? So chances of flipping to one side or the other is just right 1 out of 2, right? Because someone either picks heads or tails, and there's only 2 possible. So the probability of flipping one versus the other would just be 1 over 2 for a coin. Okay, and then as long as the coin is a normal coin, I suppose, we make 2 assumptions here. Okay, so we make 2 assumptions. And oops, I missed an M here. That's M. Assumptions. First is that all outcomes are equally likely. Okay. And then number 2 is that all of our probabilities add to 1. Okay. And I apologize for the writing here. Um, it's not as legible as on the board, right? But anyway, probabilities add to 1. So you add up all of our chances there, they're going to add to 1. So we'd also want to define one more thing. We'd say if you flip a coin the first time, then it doesn't affect you flipping the coin the next time, right? So we're assuming that a person flipping a coin, they flip it the same both times. So we'd say that they're independent events. So we'd say independent events. Okay, so we'd say one outcome does not affect the next. Okay, trying to fit that in there, right? So one outcome does affect next. So if you flip a coin 9 times and you get all heads, it's not going to change the possibility that you would get a heads the next time. Although it would seem that at some point, right, you're going to have to flip a tails. Okay, so that's that, and let's look at a couple examples here. So if we had a coin, and in the book, you can look at how it's worded, but it says a fair coin, right? So a fair coin, it's a very uniform coin. There's nothing weird about it. It's tossed 3 times and comes up heads every time. This is what is the probability that on the next toss it will come up heads? All right, so that last thing that we said is that one outcome does not affect the next probability, right? So for example 1 here, they asked what is the probability that it will come up heads the next time. So we just say probability and we put heads in parentheses. So we pay probability of heads. And since they're not dependent, we just say that's 1/2, right? There's one possibility that we're looking at, and it's 2, right? Okay, and then if we had example 3 asked, they said that a single dice is rolled, and the results are 1, 4, and 3. And then it says, what is the probability that the next roll will produce a number greater than 2? Now, in this case, right, greater than 2, if a dice is 1 to 6, then we can write down all of our possibilities, right? We say 1, 2, 3, 4, 5, and 6. So they said probability, and they said greater than 2, right? So we just look at how many numbers are above 2, right? So then we could, if we were going to look at those, we'd say, okay, it's all of these right here. So how many outcomes are we looking for? We're looking for 4, right? And there's 6 possible outcomes. So we'd say it's 4/6, or we could go ahead and say 2/3. Okay, and then for this next example, so I'm going to go ahead and do a new one. So we have example 4 here. So example 4 says that we're rolling 2 dice. Okay, so 2 dice are rolled. What is the probability that the sum of the numbers is 7? Okay, so we say probability and then we say sum is 7. It's greater than 7 actually, right? Or wait, is it 7? No, sum is 7. Okay, so let me go back and okay, that's where we gotta be clear. Sum is 7. Okay. So if we're gonna figure that out, we're rolling 2 dice, so there's 6 possibilities for each dice. Right, so then we could actually make a chart and actually show us the chart here. But if we wrote it out here, we could say there's 1, 2, 3, 4, 5, and 6, right? That's the possibility for one dice. The other dice is the same, right? So you could roll a 1, 2, 3, 4, 5, and 6. So if we both rolled, if they both were 6, then we get 12 down here, right? And then we could fill in all of our gaps right here. So we roll a 1 and a 1. Okay, I'm gonna make this, it's like a table kind of here, right? We'd have a 2 here, and then we can make all of these things right here. So we roll a 2 and a 1, then we get 3, 3. And then for this we get 4, we get 5, 6, 7. Okay, so basically if you look at the chart there, and you count the number of 7s, or you filled in this chart right here. So if you think of this right here, if you roll a 6 and a 1 over here, we'd also get 7. So if we rolled a 5 and a 2, we get a 7. And we got a 3 and a 4, we get 7. And then if we rolled another one here, right, if we rolled a 4 and a 3, we get 7. 5 and 2, we get 7. Okay, so I'm just trying to show you guys here, right? So this is if I rolled 5s here, so I rolled 4s here, I rolled 3s here, I rolled 2s there. So if I count the total number of these, and then we have 1, 2, 3, 4, 5, 6. Okay, so for the top number, I'd have 6, right? So that's the number of outcomes I'm looking for. And if you think about this little table that I drew here, since each dice has 6 possibilities and there's 2 dice, then the total number of outcomes is just 6 times 6. Okay, so that's the total number of outcomes. So this is possible numbers, right? Or possible outcomes. So if it's 6 over 36, then we just say that the possibility for me to roll 7, I have a 1 in 6 chance there, okay? All right, and so then when we go to our next little example, so we're going to look at back-to-back events. Okay, so back-to-back events. Then we simply just say that we're going to multiply probabilities. Right, because everything has to align in order for that to happen, so multiply those. So for example, 5, we're told, if you look in the book, right, it says the probability of rolling of getting the coin, getting heads, heads, tails, and tails. Okay, so we could write this as probability, and then we'd say heads, heads, tails, tails. Okay. Now, if we have a coin, right, each time, right, so let's write it for the first time, the probability of getting heads is 1 over 2, right? It's related for 1 over 2. And then the second time, it's 1 over 2, it's 1 over 2, it's 1 over 2. We're just going to multiply these together. So if we multiply these right here, we have 2 times 2, which is 4, 4 times 2 is 8, and 8 times 2 is 16. So the probability of it happening in that order is 1 out of 16. Okay, but it's certainly possible. And one of these something's going to happen. It's either going to roll tails, heads, heads, or one of those combinations, right? Because there's only two possible outcomes. Okay, so then let's look at we're going to look at one more example here. So example 6. Okay. So example 6 we have here is again with spinner. Okay, so a spinner has a 1 through 4 possibility. Okay, so let's see, and then they asked what is the probability of rolling a 4 and then rolling a 3. Okay, so we only have 4 options, right? So we know that each time we have four options here, and then the chance of rolling each one of these each time is just 1, right? So then we just have 1 over 4, 1 over 4. So we just have 1 over 16 for that. All right, and that's it for lesson 70, and then for lesson 71, we'll go ahead and look for that one as well.